Can I start?
Yeah.
Okay. So hello everyone, and welcome to this year's DevFest. So turns out I'm opening, and to wake you up, I'm going to give you a talk about a very interesting topic in Android, which is how to make your UI code modular. And I'm working for a Canadian company called Counterpath from our Serbian office, and what we do is we build a VoIP app, so calls and chat and video calls and so on, and we have a lot of brands, a lot of customers that require modifications to the core app. So we basically have one template that we change for the customers, so it complicates things a lot, and we built a framework to battle all problems we had. And this is basically what we did. And I'm looking for feedback. I'm looking for stuff that we missed, that some of you may say, okay, you missed this, and help us. I'm looking also for people who are interested to help open source this. And okay, so an introduction with examples. So what do I mean by having a modular UI code? Well, to have responsive layouts. So on larger screens, you increase the padding, for example. To change the view positions if you have a larger screen. Also to have different item lists on different devices. So on tablet devices, you have more space. You can reflow your content. Then you have a list presented as a grid on larger screens. For example, if you have more space, you would want to show a bigger picture, maybe show a little bit more of that text you have, descriptions. Then this is a sample app that just rearranges the list differently on different devices. So another example is to display the same content in different containers here, and our new best friend, the split screen. So we have to compress the layout vertically and allow it to scroll. So this is another problem for people who are building UIs. And this is the app we are working on. So it's completely different on tablet and smartphones. On tablets, it shows these screens on the left side pane and shows the dialer settings in pop-up windows. So it's completely different. And previously we had two distinct apps, two distinct projects that reuse only parts of the code, and we're trying to merge all of that into one, but still keep all of the modularity we have, and not compromise with decisions that we made because of the requests that came from clients. So what we did was we basically checked out everything that Android offers. We checked other libraries, other frameworks, and because our app is very big and very complex, we decided to build our own. It seemed like something worth investing into. And so what Android SDK helps with is screen sizes. So this was introduced in the early days of Android, and we don't use it that much, but it's there. Next, we use long and not long somewhere, not always. Also, Android helps with device orientation, obviously landscape and portrait. Android also helps with densities, so we use this for icons. We're also trying to go with vectors, but it's a huge problem because our clients deliver the icons for us, and it's a bit problematic to ask them to create vectors every time we want to change something. And obviously density pixels instead of pixels, we don't need to multiply. So this is what Android SDK offers out of the box. So for phones, we just use the values and values land qualifiers. This falls, the devices that fall into these two categories are phones and large phones. And then smaller tablets, 7 or 8 inch tablets, fall into this category. So smallest width 600 dp. And large tablets fall into the 720 DP categories. So we support over 1,000 different devices, and we managed to put them, all of them, into one of these three categories. So for us, it's been enough. I know that there are cases that don't work, but these three cover 95% of the devices we support, so it was okay. So with Android layouts, what we try to do is make more styles, make more dimensions, and make less layouts. So if we create a new layout for every little change we want, that will create just a bunch of new layouts that are not very easy to maintain. So if we want to change an icon position, we don't create a new layout, we just do it through styles or through dimensions, like adjust margins. Next up is we have a practice of printing and slicing UI. So our designer draws something and then we slice it up on paper. It's actually really a fun exercise, and we have a lot of different pieces of UI laying all around the tables, and then we just connect them into the app, and it's much easier to see which parts of the UI are reusable and which parts of our UI are self-contained. So it's a fun exercise. Also, what we do is we try not to create dynamic containers. So we try not to add new layouts at runtime. So we try to create everything statically through XML. And when we create everything statically, we always know where our content is going to be. And it helps a lot with maintaining the code after we publish a feature. And because we're merging these two apps into one, we're now reusing the phone UI in tablet containers. So if we create something for the phone, we try to reuse it for the tablet. So just put it into a smaller container on tablet, for example, on the left side. And then on the phone, we just place it by match parent, which is, it fills the whole screen. So what we have tried before is MVC. From architecture standpoint, this is a very common pattern, and people mostly do it like this. So in the model layer, they put SQLite, shared preferences, whatever. And in the view layer, they put their XMLs, obviously layouts, and the fragments. And in the controller layer, they create their own controllers or just put everything into main activity. So we had this problem. Main activity was the main controller, and it had over 15,000 lines. So don't do that. It's awful. It's very difficult to maintain. And so we tried another approach. This was actually abandoned really early on, but we tried it anyway. So the model view model, the model stays the same. The view is a bit changed. So what we did was fragments were a part of the view layer. Views, custom view groups were also a part of the view layer. And then in the controller we had, for each fragment we had a UI model that closely represents the UI. And this didn't work because our UI needed to change a few things at the same time, and then it had to change for tablet, and then it had to change for specific brands. So this created a lot of ifs, if else, or switches, or whatever. And we figured that this was not the right approach for us. And the approach we picked was the MVP. Turns out it's the most popular approach for Android. So for MVP, in the model we use SQLite and share preferences and our own settings storage. And for the view, we obviously use the layouts and custom views and custom view groups we create. And in the presenter layer, we use the main activity, but it's really small, like 7 lines of code. I'll explain how later on. And we use the fragments or our own components. I'll talk about that as well. So there are two variants, most popular variants of MVP. One is the passive view, and the other is the supervising controller. So here's what each of them does. What we did is for some screens we use the passive view variant. For some screens, we used the supervising controller variant. So somewhere the first one was better, somewhere was the second one. In most of the screens, we did the second one. So this is how we started working, and it's been paying off for us. It's a lot less work right now, and this is how we organize the components. So in the view layer, everywhere, all of these marked with a plus are the components we added. So you will get the presentation link later, but right now, if you see the presentation layer, like we have 5 new components. We only use the cursor as a standard Android component. This is the Fragment Lifecycle. I've picked this up somewhere from the internet. So everybody hates fragments, and nobody is doing anything about that problem. And people are constantly complaining. So we measured the effort to fix this, and it's not fixable. So when you look at the Android lifecycle, you have the service, the activity, the fragment, the application, the dialogues. All of them have different life cycles. So to sync them all up, it's very painful. So it's understandable to have that kind of a diagram from the previous slide. It's very understandable. It's really complex. So when they all have different life cycles, and we want to fix something there, can that even be done? Like, it's very complicated. So we spent around 6 months figuring out. We had a bit of time. So we spent around 6 months figuring out what to do, and we had a discussion whether to create a custom UI entity that would replace fragments. And then we saw Mortar and Flow by Square, and Square did it, and they were really happy. And we decided, okay, if Square's happy, we want to be happy as well. And we created a new UI entity. So when I say page, screen, fragment, whatever, so consider that a self-contained UI entity. Whichever term I use, it's the same thing. It represents the same thing. It's a self-contained block of UI. What were the drawbacks of this? So we had, this was unreliable. We had a lot of bugs. We wanted to use AppCompat, but then AppCompat was upgrading and updating every time, every month, and we had new bugs. Whenever AppCompat updates, we have new bugs. So this is the main drawback, actually. And obviously the API levels. Well, currently we support API 16 and newer. We could support API 14 and newer, but it was just a cosmetic thing. We wanted to drop off these 1 or 2% of devices just to keep our code a bit cleaner. It's a bit cleaner. So that's, yeah. And the fragment caching mechanism was awful. If you want to create your own entity, you need to think about caching. And the fragment caching is really bad. So we definitely decided to ditch fragments and use our own components. So a bit about the Android activity. The problem, when we wanted to create our own components, the main problem was the context is everywhere. We wanted to decouple as much as possible so we could make it modular. And the problem is the context is everywhere. Another problem is when you have a tightly coupled mechanism that's provided by the platform, it's very, very difficult to decouple. But we think it's worth it. So we listed all the components we need, and those are here. And we divided them into these 3 groups: view, presenter, and model. I've put that on one of the previous slides. And it's actually possible. It's a lot of work, but it's possible. Another thing to consider is how do we approach Android lists? So Android lists were previously implemented by using a list view where you had to do a view holder pattern by yourself, or you install a plugin for Android Studio and it generates the view holder, whatever. Now they switched to Recycler view, which is much more flexible. but in turn it's also more complex. It's very complex to people who are new to Android. They need to understand what an adapter is, how the view hierarchy works, how the touch interception works. It's a lot of work. And these are the components from the recycler view. This is what Android offers by default. And we decided to decouple, but not all of them. We decided to decouple the adapter component into two different components. So one is the data provider, and the other is recycler adapter. So here's an example. For when a recycler view wants to draw its children, it needs to check whether its data is prepared. So it calls into the adapter. The one that's marked with an exclamation mark, the green one, it's split into two, so recycler adapter and data provider. By default, that's the component called recycler adapter. It's one component, so we split it into two pieces. The adapter only deals with UI, and data provider only deals with data. So this means that if we have, here's an example, if we have a contact list, so we will list all contacts in one screen, and we also have our own in-app buddies, so friends. It's very similar. The UI is exactly identical, and we wanted to reuse that UI code. So what we did is we reused the item layout. We reuse the code that draws, so it's inside the recycler view. We reuse the layout manager. We reuse the bit where we create, inside the adapter where we create view holders and update them. We reuse all of that code, but we don't update data inside the adapter. We have another component that's called the data provider that updates the data. It can do that asynchronously or synchronously, or it can be static, whatever. It's just, so we have a list of contacts and the user clicks to show the friends. We just change the data provider because the UI is the same. We show the picture, we show the name, we show the status, we show, I don't know, the first number. We show the same data, but just from a different data source. And that's why we decided to decouple that. And it's been really helpful. We could reuse, previously we had, I don't know, maybe 50, 60 different adapters, and now we have like 20, because we have around 60, 70 screens. Each of the screens has a different use case, so it dropped by 60, 70%. The number of adapters we have dropped by 60, 70%. This is the big part. And oops, okay. So how did we update the lists asynchronously? Well, if we hold the data inside the presenter layer and just display it in the view layer or in the screen, so what we do is, obviously UI events need to go to a UI thread. We had a big discussion whether to use threads or async tasks or RxJava. Well, it turns out if you decouple and pull out the data provider, it doesn't matter which approach you use, because the data should always be ready, even if it's loading, your item count is 0, so the list won't display anything, and you can just update in the background, and then you notify the adapter refreshes the list with the latest data. So it's the data loading mechanism doesn't really matter. Somewhere people used async tasks, somewhere they use RxJava, somewhere they use just regular threads, whatever. But the point is, if we decouple, it's very easy to change what we use for actually loading that data. So how do we push events upwards to the UI layer? We tried auto, and auto was bad for us because it didn't have any syntax check. I don't know about now, but at the moment we tried it, it didn't have any syntax check. So it's great, it worked, but no syntax check. We also tried Green Robot. It was a great piece of software, but we wanted to modify it. We wanted to order our events. We wanted to reorder them afterwards. we wanted to remove some of them, so we had to do a lot of modifications to the event queue, and we decided to also to ditch that and do our own. And when we did our own, we had a problem with swarm of events, so we had something like 20 events per screen, which is really a lot. If you have a single event listener, that's a switch case with 20 cases, so that's a lot. Yeah, and so this problem is still standing. We don't have a solution for that. We have some good ideas, but if we find something, I will definitely update here. Sorry? Event bus? I think somebody is using it for specific events, but we haven't really. Currently we have our own, and we're trying to fix this big switch case, and maybe event bus would help. Maybe one of the solutions would be that. We'll try everything, whatever works. So another problem we had was intents. We decided to handle all intents in one place. So by default, you get, when you start an activity, you get an onCreate call by the framework, and inside that call, you can call something like getIntent and obviously check if that intent is null, because it can be, and then check if it has an action, also can be null, and you check a few null pointers, and it's very defensive. And then you have to do the same thing on a new intent. So that's something we didn't like, and we didn't actually care about differentiating these two situations. So if an event comes in, if an intent comes in, we just want to handle it. We don't care about whether it came in through the onCreate or through the onNewIntent method. So we did that using the intent handler. Intent handler is a component that attaches to the activity and to the onNewIntent method, and it queues every event until the UI is ready to handle it. And we typically so we typically handle it. We typically handle it in onResume method if possible. So we queue everything and wait until the UI is ready, which is most likely in the onResume. And when we don't know where to go, like we have a login screen, we have a splash screen, we have a setup wizard now, and we have a few other activities that need to be shown before we go into the main activity. So we built a component called the activity resolver, so you can always ask the activity resolver where to go. So you can just say, okay, new intent, go there, and give it to the activity resolver, and the activity resolver would change the destination activity based on the current application state. So it's hooked into our controllers, it's hooked into our events, and we can just easily go to the right activity where we should go. So it never happens that user clicks call button and goes into the activity without previously logging in. That never happens with this approach. So it's, as you're probably thinking right now, it's a lot of work, but it's worth it, because right now we basically rebuilt the whole UI in only 2 months, and it took more than 2 years to build it from scratch the last time they did it. So it's a lot less work, but it was a lot work building the framework. And I'm going to talk about how it all works technically, internally, with screens and presenters, creation, destruction, and so on. So the pages or screens, or you can even use fragments if you want. It's just, the point is that it should be a self-contained block of UI that does nothing else but the UI. And it should have a presenter that's used to prepare the data for that block of UI. So it's mapped one-to-one, and you should always expect to have a presenter when you start a new screen or a new page. And the big thing we decided to do is to handle dialogues inside these pages. So if you wanted to show a dialog, you would say something like new dialog.show, and then it will attach to the activity, and it will probably cause a memory leak if you don't dismiss it manually. So that was a problem. People forgot to dismiss it, and this way we prevented it. So we have a method called show dialog. You give it an identifier, you give it a data. It's a simple bundle, and in turn the framework calls the onCreateDialog method, and you just create the dialog there, and the page internally manages the dialog state. It manages when it should be hidden, when it should be dismissed. If you want to persist it, you can also set a flag to persist it, meaning that the next time the page shows up, we again show the same dialog with the same data. This is very useful for rotating. So when you rotate the device, everything gets destroyed. You get the new on create, on start, on resume, and so on. And we again recreate the pages. We recreate the dialogue. So it's all automatic. And handling dialogues inside the pages helped a lot. The question I get often is, do we have complex dialogues? So yes, we do. We have pop-ups that are, for example, pick a contact, pick a friend, pick a person, somebody from your list. And this is a big complex dialogue, and we reuse the data provider, we reuse the adapter, and we can even reuse the screen or the page, and we can contain the page inside the dialogue. So it's very modular. So we decided definitely to keep the presenters alive even when the screens are destroyed. That way the data is always ready. When you go away from that screen, go back, presenters are always caching the data. It's not big overhead, it's relatively small. Okay, so I'll just speed up because I have a little bit of time. Okay, so we needed...
you have 4 minutes till end.
Okay. We needed a common navigation API, something like this example. I'm missing a line here, and a very important line. Okay, I'll try to explain it. Okay, so right now we have something like navigate. From each screen we can do something like navigate dot with bundle and give it a bundle, and then continue on with to pages dot login. So all pages are listed in this one class, and the framework instantiates the page and tells the other parts of the framework how to go there and how to show the page. So the component that actually does that puts pages into layout containers and creates them and destroys them is called a page manager. It's a lot of code. It's basically what Fragment Manager does. And if you have a small app, you can just use the Fragment Manager. And the big thing here is the coordinator. The coordinator is something that wraps around everything else. It uses the page manager to show and hide. It holds the navigation interface. It basically knows where each page needs to go. So for smartphone, if you say pages, go to page.login. On phones, it will just show it in full screen. On tablets, it will show it on the right pane. I don't know, whatever. But the point is that coordinator knows where to show the screen and how to do it. So the coordinator also handles back up and holds the intent handler component. It's just the wrapper around everything else to avoid using activity for that task. And if you put the coordinator inside the screen list, it also becomes a screen, and you can split it into 2 parts, the UI part and the presenter part, and then you can also have that part decoupled. This is an example of that. So on the left, you have this UI on the left, and on the right, this is how it's layered. So the coordinator is the left minibar, the top toolbar, and then there's one screen in the center. It's the content page, and another screen, a navigation drawer page. And the coordinator holds both of them. The coordinator knows how to show them, hide them, let them communicate between themselves. So it's a lot of technical work, but it's just something that splits, again, the activity code into two pieces, the UI and the presentation code. So this is a similar example for tablet. The coordinator is all around, and then you have the right pane and the left pane. To keep the pages modular, we could use Gradle flavors. That's one of the things we want to use, and the other is a page resolver component, another component that just knows which specific page to load. If we have branded pages with specific brand logos and so on, we use the page resolver to create that page instead of the template one. So it's a small component, right? And just to mention the drawbacks of this approach, it's a lot of decoupling, a lot of cosmetic work, like more than 6 months, a lot of method references. If you're close to that 50, 65K limit, then this is going to push you over the edge. And we have over 100,000 methods, so it's really something we just included multi-DAX and it works. It's difficult to switch to. It makes sense only for complex UIs, and we need to work on team education. And currently it has limited support because it's still not open source, but we're trying to open source it. And that's why I said I wanted to hear some feedback from you guys. And if you have anything to add, anything to remove, if you want to contribute, just let me know. And this is basically it for our framework. I'll post the presentation online so you can take a look at it again. So if you have any feedback, questions, now is the time. Here are my accounts, you can ping me there or just ask here.
Давайте поблагодарим докладчика.
Thank you.
Если у кого-то есть вопросы, у нас есть 10 минут, чтобы это обсудить.
The person who asks first gets the T-shirt for bravery.
Thank you for your lection. I have one question related to recycler layout and your architecture which you described. What is your proposal for a situation when you need to show, for example, loading spinner or error message? Should we do it inside adapter as item of recycler view, or should we send some callbacks to activity?
No. So what we do is we have our data providers also have flags whether the data is loaded or is loading still. So when we ask the data provider, which is in most cases the presenter itself, we know from the screen, and we also know from the adapter whether the data is still loading or it's loaded. So depending on that, from the screen we show an error message if it failed. We show there's nothing here if it's a zero data set, and we show we remove the recycler view. We don't put an item inside, but it was an internal decision. It may not work in all cases.
So you mean that this provider could be accessed from activity, for example, and from adapter?
So you create your adapter. In the constructor, you need to give it a data provider. If you fail to do so, it crashes. So you give it a data provider, which is in most cases, it's the presenter itself. So the presenter provides the data for the list, and so the screen has access to the presenter, and the adapter has access to the presenter. So it's the same component. Yeah.
Thank you.
Yeah.
How do you test all this stuff?
Can I skip the answer? We currently don't test it. It's under QA live people, humans who test it. But the only way we could test this is probably integration tests. I mean, we could test the framework and components easily because it's plain Java. Well, not Java, but plain Android SDK, we could test it with unit tests, but actually loading the data, showing it, manipulating the views, it all happens through the UI threads looper queue. So it's a bit problematic to test, but we could do definitely one approach would be integration tests. Right now it's under a lot of QA, but we are planning to test it. Well, the first step will be integration tests.
Someone else? Okay. Thank you for your speech.
Welcome.